So yeah, it is quiz time, ladies and gentlemen. So going to give you 5 questions, 10 minutes. Please, please, please. Got the crowd is increasing now. That's wonderful. I want to see every one of you punching your answers in. If you're struggling, if you run out of time, just make a guess, move on, just like you're on a real test. The better the data is, the better I can tailor this to what you guys need. I'm going to make the assumption that the people watching live are fairly representative of the people that might be watching this later. Helps me a ton. A lot of the time what we see in the live chat, we get messages from the people who are really strong at this stuff. So please, if you're struggling, I really want those forms filled out. If you get obliterated, wonderful. That tells me that 2 minutes isn't enough. We've got some issues to work out, and we can tailor it from there. All right, you're back. Fantastic. First question, kind of an embedded, so mix of conversion and rate, pretty common thing you see on the GMAT. I'm just making sure that you're nice and systematic with this. Certain banana slug can crawl X centimeters per minute. How many meters would it travel in Y hours? So what do we need? Anytime you do a conversion, we're saying, okay, what are our starting number of units here? And what do I want? I want meters per hour. This is my brain on exhaustion. I lose track mid-sentence now. X centimeters per minute is how many meters per hour? Pretty easy to get there. 1 meter over 100 centimeters. That 1 minute. I'm sorry, we got one. Wow, there goes my brain, kids. 60 minutes over 1 hour. My units cancel the way I want them to. Minutes gone, centimeters gone. I got meters per hour. That's good. Pretty straightforward from here. I basically got 3x over 5. All I have to do is kind of punch that back in. I think for most of you, this is not an issue. Rate formula, it's barely even a formula. It's almost more like a definition, right? Guiding light, if you get stuck, maybe this can help get you unstuck. Work is always equal to how fast you're doing the work times how long you spend doing it. We want to know how many meters does this guy travel in Y hours. Y hours, there's the rate, 3x meters per hour, 3x over 5 meters per hour. And you're out of there. Pretty straightforward. 3xy over 5. Answer there is A. Not seeing a lot of struggles there, which is fantastic. So question number 2, really no struggles there at all, despite Shobik's complaints about it. Toss it on the screen real quick. Why isn't that showing up? Huh. For some reason, it's not showing my screen again. Don't know if that's a little bit of a technical issue we're having. Abhijit, can't seem to show the slides. Okay, go on without it. Water from one outlet flowing at a constant rate. Can fill a swimming pool in 9 hours. So we've got outlet 1. We got outlet 2. When things are working together, you add their rates. So what are their rates? First guy filling a pool. If you need to go through this, go for it. I want to get that rate. It's doing it in 9 hours. Must be 1/9. If it helps you to punch all that in, go for it. Don't be shy about it if you're new to this stuff. Rate for the first one, 1 over 9. Rate for the second one, 1 over 5. When things work together, you add the rates. Fractions, decimals, doesn't matter. Variables, add the rates. Things work together. 1/5 plus 1/9. Pureed brain, I'm going to go 14 over 45. Not sure if that's right. I think that's right. Somebody correct me if it's wrong. Approximate number of hours to fill the pool. The work is still just 1 there. Flip it around to get the time. 45 over 14. That's a little bit more than 3. Which gets you the answer D. Okay, I'm still having an issue here. I still can't share the slides at all. So Abhijit, Nikhil, I don't know if there's a way to fix that. Oh, I see. He's out of the stream. There we go. That got removed. So machine owner, again, no issues here really. I think we got 80% correct from the live group, pretty much on the button. Going to go through it fairly quickly. And guys, if you're watching this and I'm going too fast for you, you can go on over to the GMAT Ninja YouTube channel. Please subscribe if you like what we're doing. The other guys that are on that channel are smarter than I am, better looking, taller, all the things. Branson's been doing racing conversions, a couple lessons on it. So 2.5, 3 hours, kind of walk through the basics and kind of get you out of the advanced stuff if you need it. For this crowd, I'm going to go pretty quickly. We only have an hour. Machine owner wants to estimate how many widgets his machine can make in a given amount of time. Knows it takes an average of 1/p minutes. An average of p minutes to make one widget. So what's his rate? 1 widget per p minutes. Fantastic, party on. How many widgets can it make in Q hours? Same kind of deal we were doing before. I want to convert this to widgets per hour. So 60 minutes is 1 hour. So 60/p is your rate in widgets per hour. And multiply that times Q, and we got it. So it should be 60p/Q. Answer choice is C here. Next one. Again, a little more struggles here. We're down about 3/4 correct, roughly. And that might be more of a time thing than anything else. Broadly speaking, 2 ways to do this kind of question. One is you can go straight algebra. For some of you guys, that's your happy place. You want to go super algebraic here, you certainly can. No shame in it at all. For most people, what I'm really interested in here is kind of getting you to this idea of how can you be intuitive about this kind of question. We really have a concept here when 2 things are chasing each other. One thing's falling behind the other. The key concept here is catch-up speed. So if I'm driving in a car and I'm driving 58 miles an hour and my buddies are behind me driving 50 miles an hour because they're slow, every hour I'm getting 8 more miles ahead of them, right? That's the concept here. Car A, 58 miles per hour. Car B, 50 miles per hour. So each hour. So A gains 8 miles. So from there, it's easy. So A starts 20 behind, ends, I think it's 8 ahead. And that's pretty much it. It's got to catch up and get ahead by 28 miles. It's got to kind of overcome an extra 28 miles, 8 miles an hour. So that's going to be 3.5 hours. So 28 divided by that catch-up speed gets you to 3.5 hours. So answer there is E. And again, pretty nice work on this in the live group. Number 5, this is where I heard a lot of complaining out of the live group. I didn't see a lot of errors. So again, about 3/4 got it correct. A little bit of struggle here. So 12 identical robots take 4 days to build a spaceship. How long would it take 3 of the same identical robots to build 2 spaceships? A couple different ways you could do this. You could go straight algebraic with this. Again, if that's your happy place, don't let me stop you. If you love the algebra, by all means do it. I think we're going to run into a question later where I think it's easier to do it algebraically. That's kind of a similar sort of setup. So we'll get into that when we get to that question. Here I'm going to do it a little bit more intuitively and just say, well, all right. So if we got 12 robots, it takes them 4 days. And this is for 1 spaceship. Well, what happens is I cut so I'm trying to get to what happens with 3 robots. I mean, this question, again, we're kind of giving you the warm-up ones here first. What's nice about it is I know that it's not that hard to go from 12 to 3. So I can say, well, what happens if I cut the number of robots in half? Intuitively, cut the number of robots in half, we're going to double the time. So go from 12 to 6 robots. Now it's going to take me 8 days to build that 1 ship. 3 robots, we're doubling again, right? We cut the number of robots in half. Going to take us twice as long. 16 days. Again, for that 1 ship. Only quirk here is now we're building 2 spaceships. Multiply that by 2. And we got to 32. Okay, zooming out a little bit. Let me go to that question. So we got a little bit on rates. So we got another 40 minutes or so on this. What is it that we're really after? Like what are the skills? Rates aren't a huge topic on the GMAT either. And I can double check the data that we have at GMAT Club, from the autopsy performed on those first 2 free official MBA.com tests. But I want to say it's something like 3%, 4%, 5%, somewhere in that range. It's more important than probability. But I think between distance and work problems conversions, like we're right around, I think 5% if I remember correctly. So pretty small. So out of your 31 quant questions, how many are you going to see? 1, maybe 2, maybe get lucky and see 3 of them. So why do we even spend time on it? Why bother? Couple comments there. One is that I think rates are, there are so many kind of generic algebra problems, word problems that require some translation. And I think rate problems are a really, really good way, especially if you struggle a little bit on the quant, really good way for you to kind of get better at that hygiene and get better at setting up variables and making them really work well for you. So that's one thought, is I think that those skills spill over in other questions, which is part of why I think I kind of overrepresent rates a little bit when we're teaching our private students. So I think it has value there. So if you're watching this and you're not super strong at quant in general and you feel like you struggle on word problems, there's things you can get better at doing rates that are going to make you better overall on the test on a much broader swath of problems. That's thing one. Thought number 2 is what I want you guys to be a little bit careful of. This is another one of those topics where people obsess. So again, theme for this marathon is, what are the things that you're really doing wrong on these different topics? One of the most common errors we see on rates is it's obsessing over the rates. So yeah, I can talk about spillover skills. I think it's worth getting good at a lot of the foundations, maybe even going a step or 2 beyond the foundations. I think that can be really good for you, even if your goal is just a 47, 48. But I see a lot of obsession over kind of these, I'm going to go through and memorize 20 or 30 different variations of rate questions. We see that behavior a lot. Rates, I think, really bug people. I think they kind of stick in your brain for some reason. A lot of people walk out of their tests and say, hey, what went wrong for you? The train question. The train question, how many of those did you see? I didn't see any on this test, but I saw it on a practice test and it really bugs me. It's like, yeah, there have been like 2 or 3 of those released ever where the 2 trains are going at each other. We're going to go through one, but it's one of those things that people just obsess over from the beginning of time. Test prep companies, we tend to listen to our students who are saying, the train question, let's do the train question. It barely exists, guys. You're almost certainly not going to see it on the test. If you do, let me know. It's going to happen every once in a while, but they're really, really uncommon. So don't obsess, don't spend too much time on it. Really think about bang for your buck in terms of your composite score. Are you getting it off of, obsessing over the nuances of rates? Or are you going to get that boost in your score by spending a little bit more time on, I don't know, reading comprehension, critical reasoning, cleaning up your careless errors, getting some more sleep maybe. Again, do as I say, not as I do. Sleep is really good for your score. Okay. So that's the big picture here. Going to get at some kind of spillover skills in the algebra on the next couple questions. And then depending on whether I think I can get these questions right, I've got a couple of really hard ones toward the end of my deck here. We'll see if I think it's worth going through those. All right. All right. I actually love this, Maria, because you're bringing something up that I think is, I know you're having fun with everybody. And I love it. One thing psychologically, because I see this all the time on the forum. Oh, this is a trap. This is a trap. Bad psychology, guys. Maria, knock yourself out. You don't have to deal with this test. And it's fun to make these jokes. I really enjoy it, especially when everybody's kind of agreeing that this is wildly appropriate, and I really like it. But since it came up, don't think of the test as being traps and tricks. You're just going to make life harder on yourself. You're going to start hallucinating traps. We see this all the time. I'm not sure that the particular crowd watching this, I think you guys are consuming a lot of GMAT content, probably less likely to make this mistake, but we hear it all the time. It's like, oh no, it's a trap. Don't pick C, it's a trap. Don't pick E, it's a trap. Hear that kind of stuff all the time. Try to get that stuff out of your head. It's not helping you a whole lot, unless it's just for entertainment, which of course this is. All right. Pretty straightforward question here. So that's interesting. Okay, oops, sorry, didn't mean to show that. Okay, so getting some funky stuff there. There are ways you can intuit this, and I think some people that got the answer really quickly just kind of looked at it and said, well, it's twice as fast, so it's going to take twice as much time, and so 6 hours plus 12 hours, and it's 18 hours, and kind of did it really, really quickly. If you can do that, awesome, cool, run with that. I'm going to go through the algebra here. not because it's the best way to do it, but I think it brings up some useful things as far as how to think about variables that I think spills over well into some other kinds of problems on the GMAT. And if you can't see the shortcut here, that is totally fine. I want you to be able to do it methodically if you can't see the shortcut right away. Okay, we know that these things are working together. So it's always going to be the case that you add their rates, things work together. So we're adding the rate of the small guy to the rate of the large guy, and we're getting their combined rate. What's their combined rate? 1 tank, 6 hours. Again, if you're new to this, you need to do this stuff. Work 1 times 6. 1/6 is your rate. If you need to do that, go for it. If you can just look at it, eyeball it, and go 1/6, that's totally great too. Different strokes for different folks. Don't feel like you have to race through it. If you need to be methodical, take the time, get it right. Okay, what else do we know? Small pump takes twice as long as a large pump. Again, if you need the training wheels, you can kind of say, well, if this is TL and this is 2TL. Now notice here, I'm putting subscripts in. So if I need those training wheels and I can't just jump to the shortcut, again, awesome if you can. And everything I'm saying here is going to be kind of boring for you. But for most people, for most people, you're going to need a little bit of that time to kind of walk your way through it a little bit. Get request shows on the screen, so I'll do that briefly. If you just say T here, you risk getting yourself confused. There's a risk that if you just say T, you're going to lose track and go, wait, which T was I solving for? If I just say R, which R was I solving for? That's why on rate questions, I would just get in the habit of making sure that your algebra means something to you. Make the variables meaningful. Be nice to your future self 2 minutes from now, so that when you look at that variable later, you should be able to say, oh, okay, well, that's the time for the large one. Now here, look, the other shortcut, instead of going through all this and kind of saying 1, and I can get kind of this funky thing, and it's fine. And I can solve for it this way. My preference here, I'd rather not get the fractions and the rates personally. Again, you can do it this way, and that's totally fine. I'd rather just recognize that, hey, if the small one takes twice as long, it means it's twice as slow, right? So it means that its rate must be half. So I could say that the small one has a rate, call it RS, and this is 2RS. And then I'm basically done here. So I'm a couple really quick steps away from getting the rate for that small pump. And again, I'll always take that moment to just double check and make sure that I'm not flipping it around and putting the 2 in the wrong place. So small pump, rate of the large pump has got to be bigger, faster pump. Okay, great. So there's my equation. That's it. 3RS equals 1/6. So R/S equals 1/18. And again, if you need the training wheels, don't be ashamed of it. Go ahead and do it. You're better off spending the extra 10 seconds and getting something wrong because you get cocky and go, I'm just going to flip it. If you need the moment, take the moment. Work, still 1 tank. Rate, 1/18. Time, got to be 18. And that is it for your small pump. Okay. Let's see what happens on this next one. Pretty heavily algebraic. I have a feeling that the particular crowd that's in here right now is not going to struggle with it, but let's see what happens. I am so with you on that, Whitney. Okay. Keep the question on the screen for a little bit here. So first hour of a 2-hour trip, car travels d kilometers. Second hour, traveled 1/2 that distance. Hour number 2, d/2 kilometers. Fantastic. What's the average rate at which it traveled in kilometers per hour? Super, super simple here. Don't overthink it. And again, I don't have a great feel for, again, I'm hearing from kind of the small subset of the group that's confident. Not sure if there's more people struggling back there. But again, just bring yourself back to basics. If you start to swim around in rates problem, you're new to this stuff, and you start to go like, wait, what? So just take a moment and go, what's average speed? It sounds really dumb, but like, what's average speed at the most basic level? Average speed, it's always your total distance divided by your total time./Well, we know it's 2 hours. That's great. We know that your total distance goes d kilometers there in the first hour, d/2, second one. So we got D plus D over 2. Our only issue here is we kind of have a fraction sandwich, but that's not that big of a deal. So G plus D over 2, I believe, is going to be 3D over 2. Stop me if I do anything silly. Divide that by 2. 3D over 4. And that's that. That's answer choice D, and we're out of here. And again, we're going to punch up the difficulty level, I think, a little bit here. No, sorry. I think the next one's fairly straightforward. You know what? I'm going to skip the straightforward one. Let's get this a little bit harder. I've got 3 more questions. I got 20 minutes. 2 of these were written by the Buñuel. So I think those are going to be fun. I don't know if they're going to melt your faces off or you're going to find those easy too. But let's do one more that's not so bad, gets a little bit more of the algebra. And then we'll get 2 of the Buñuels in here and see how that goes. You know, I really like answer choice A. We need 4/3 of a frat boy added to the party. There's an image there. Okay. 4 identical frat boys drink a keg of beer at they're identical constant rates. That's how all the parties I've ever been to were like. It's just these robotic guys just drinking beer. I had fun in college. 4 identical guys, keg of beer in 6 hours. How many more dudes do you need to drink it in 4 hours? Again, a lot of ways to go about this. There's some lovely shortcuts here that I'm pretty sure some of you guys are doing. Again, I'm going to kind of back up and sort of do the algebra nice methodically for people who need it. Do it pretty quickly. Again, if you're somebody who's watching this and need more of the basics, gone through more slowly, Branson, taller, better looking, younger, speaks Arabic, speaks Greek. He's doing a ton of rates and conversions on our channel, on the GMAT Ninja YouTube channel. Go watch those over there if you need to go through this in more detail. I'm going to fly through fairly quickly here. So 4 guys, what's their combined rate? Basically what we're saying here, it's like we have kind of rate 1 for guy number 1, rate 2, rate 3, rate 4. You add all those guys up together. I just turned a 4 into a U. What's their combined rate? 1/6. I don't need these subscripts at all. They're kind of BS here because they're all identical. So if you want, you can make it RI. You don't need that at all. It's up to you. I find it a little more intuitive just to be clear with myself on rates, just to make sure that I can be clear that, yeah, it's any individual one of these, not a combined rate. 4 times RI equals 1/6. So what's the individual rate? 1/24. What are we saying here? The individual frat boy can drink a keg of beer in 24 hours by himself. That's a good way to spend 24 hours. Better or worse than what I'm doing right now? You be the judge. Okay, now how many of these guys do I need to drink it in 4 hours? I can just multiply here to sort of get a combined rate, however many frat boys we have. So we're going to drink this in 4 hours. Again, if I start to swim in this a little bit, if I start to get a little bit lost, I can always anchor myself back in here and just say, okay, wait a minute. What's the time? 4 hours. Fantastic. What's the work? It's still 1 keg. I want to do this in 4 hours. Well, I've got the individual rate as 1/24. But the only mystery here is how many dudes do I have at this rate of 24? I can call that a variable pretty easily. Let's call it, I don't know, N frat boys. How about B for Budweiser? No. C for Coors. I'm in Colorado. And there you go. Solve for C and you got it. We're done here. So how many total guys do we need? We need 6 total beer drinking guys. Now, again, the thing that people caught, I think, pretty nicely in the live group, pull the question back up on the screen here. What's the question? How many additional frat boys? We know we need 6 total. We started with 4. We need 2 more. Answer is not 6. Don't fall into that trap. Oh no, I just used the word trap. It's a trap you're making, guys. You're the one that misread if you made that mistake. We've all done it. I've done it a million times. So the answer is not 6, it's 2. 6 minus 4, 2, that's B. Party on. Course for everybody. All right, we got 13 minutes left in this block. Which one of these do we want to do first? Let's go Fanny and Alexander. From the brilliant mind of Buñuel, the legend. Okay, no real struggles. That's great. Heart of it here. Things are coming at each other. They're 360 miles apart. And what's going on here, you got kind of their combined rate. So it's like these two things are working together, right? You combine their rates because they're working together. Imagine they're building the track if you find this confusing. So imagine they're building the track. One's building it at 25 miles an hour. One's building it at 65 miles an hour. Combined, they're building 90 miles of track per hour. And this is part of what's so interesting to me. Like, this is the train problem that people obsess over. And I don't get it, because once you sort of see that it's like, no, they're basically working together. So they're going to meet in 4 hours. That's not what the question's asking you to do, but it's like, okay, combined rate's 90, 360 miles to go, going to take them 4 hours. Not what the question is. How far apart will they be an hour and a half before they meet? Well, pretty easy to figure that out. Their combined rate is 90 miles an hour. So when they're still an hour and a half away from each other, they've got to be 90 miles per hour times 1.5 hours apart. That's going to give you the 135. All right. That one nobody struggled on. Let's give you Buñuel's next one that he gave me for this topic. And this is going to take us to the end here. This is fascinating. Suffer with me, you guys. I'm curious, for those of you here that are, here live, let me know what you're doing with this. Are you doing algebra? Be curious. Plenty of people weighing in with answers. Are you doing algebra? Are you using intuition? Just give me kind of a general sense. I'm really, really curious. Just genuinely curious, more for me than anything, to be honest. Because I look at this and I struggle here with the algebra. Now, granted, I'm an hour number. I'm not even sure. What are we on, number 15? I got to check the slides to let me know. So part of it is I'm pureed right now. Not super familiar with the question, but I'm a little lost on the algebra. I'm sure it can be done. I'm sure it can be done elegantly. I'm seeing a mix of algebra and intuition in the answers. Keep that coming, guys. I'm super curious. I'm using intuition here. So round trip, go ahead and pull the question off the screen for a second. 2 minutes before we hit the bottom of the hour, hour number 16, where I'm probably going to get my butt kicked. So I picked some really hard questions I'm not going to be able to make sense of. Looking forward to it. All right. Rates. Round trip to the gates and back is the average speed less than 20 kilometers per hour. Average speed to the gates. So I got one way, same distance both ways. That's great. You could write the average speed formula. I don't think there's any harm in that. It's probably helpful enough. Maybe it helps your intuition out getting that suggestion from the live crew. You could say that your average speed is 2d divided by time 1 plus time 2. I'm really confident you can go somewhere with that. You can. Right now, my brain's not working. I'm not really seeing how I can use that right now on a different day, different time, different amount of juice in the tank. Maybe I can get there. Maybe it's me. Maybe I can blame the sleeplessness. I'm going to use intuition instead and say, well, if the average speed to the gates is greater than 40 kilometers per hour, so super, super fast. Now, is it possible that the average speed for the round trip is greater than 20 miles an hour? Absolutely. If we ran to the gates really fast, ran back really fast, could be higher. Could it be slower? Yeah, there's kind of no real limit on this. And maybe this is where kind of this does help the intuition, having that average speed formula there. But I don't see a limit on that, on the bottom limit really on that average speed. Because, well, what if you took forever? What if it took a year to run back? Well, then, yeah, the average speed is going to be way less than 20 kilometers per hour. It doesn't really matter how fast this is. You can always slow it down on the way back enough that you can get that speed under 20 kilometers per hour. So I'm pretty confident here, but well, tell us if this is wrong. But I don't think A is sufficient. Statement 2, average speed from the gates is less than 10 kilometers per hour. This one, actually, I struggle on more here. But my intuition here is that if you're going that slow, I think you've already used up your whole time. And I'm not saying this is a good way to solve the question, but my instinct here is to just kind of say, just to get my head around it, to say, well, let's imagine that the distance is, just going to say 100 for the sake of a nice number. For that speed to be less than 20 kilometers per hour, then your time's got to be greater than 5 hours. And I know it's not that far from the gates to the Trojan horse, but whatever, just for the sake of numbers. Now, if that distance is 100 and my speed was less than 10 kilometers per hour, then that means my time is already greater than 10 hours. I'm sorry, it's 50 each way. So let's say that it's I'm sorry, I was sloppy with that. So let's say the distance one way is 50, so your total distance is 100. To have that average speed of 20 miles an hour for that whole 100 hours, then yeah, it would take you more than 5 hours. But if we're going 50 kilometers one way and we're going, I'm sorry, less than 10. My bad. So what statement 2 is saying, that speed to the gates, or from the gates, I'm sorry, is less than 10 kilometers per hour. We've used up all our time. We can't get any faster than 20 miles an hour now, or sorry, 20 kilometers per hour now. So being so slow on the way from the gates, I think puts a limit on it. And I think you're stuck under 20. And yes, this is spot on. Buñuel's questions are like Trojan horse for my concentration at this point. So I'm getting B here, and I saw almost no Bs in the live group. Buñuel, are you still with us? And is it B? Uh-oh. Is this on the forum? Can I look it up somewhere? It is B. Buñuel will trick me in hour number 24. Invite your friends. Buñuel's going to kick my butt in hour number 24. I better look at the questions. Going to be a little bit like this. I'm going to be stumbling through, getting signs wrong, but I got his logic here. Great question, Buñuel. It's a lot of fun. All right. Ran a little bit over here. Hour number 15 in the books. Thank you so much, everybody.